Alright, so now we're going to deal with simplifying radicals that are not perfect squares. Earlier we were dealing with radicals like the square root of 25, which that's a perfect square, and you know the answer is just 5. Or the square root of 49, you know, is 7. Well, what about the square root of 98? That's a little bit tougher because it doesn't come out evenly. Even if you put that in your calculator, it's going to give you some sort of crazy decimal. And I've written it out twice here because I'm going to show you two different ways to do this. They're very similar, but this is just how I like to do this. What you've got to do in order to simplify a radical that's not a perfect square is you've got to basically do a factor tree. You've done these before, like way back in the day, back when you were in elementary school, you did factor trees. So let's start by doing that, okay? The first way I'm going to show you is this way right here, and we're going to find the lowest possible number that will divide into 98 each time. And we're going to try and get prime numbers only. So prime numbers are numbers that only divide by themselves in 1. So for instance, 2 can only be divided by itself and 1. There's no other numbers that will divide into it evenly. 3 is like that. 5 is like that. 7, 11, 13, these are all prime numbers. They can only be divided by 1 and themselves. So let's take a look and see what we can divide that is a prime number, the lowest prime number possible that goes into 98. Well, I mean, it's an even number, right? It's 98, ends in an 8, so I know that 2 will go into it. Okay, well, 2 times what gives me 98? 49. Okay, now what we're going to do is we're going to start from this one. Since this is a prime, we're going to go over to the 49 here. What times what gives me 49? And again, I'm looking for the lowest possible number. There's only one number that actually goes into it here, and that's 7 times 7. So now we've got 2 times 7 times 7. So what we're going to do is we're going to rewrite that underneath the radical sign. So we have 2 times 7 times 7. And that's going to be the exact same thing as 98. We just simply broke it up into prime numbers being multiplied times themselves. And if you put this in your calculator, 2 times 7 times 7, it's going to give you 98. So you can kind of see how we got that. Now what we want to do is we want to go back and we want to circle any pairs of numbers that we have underneath that radical sign. Now you can see I'm going ahead and circling it here. We've got a pair of 7s. Well, if you take the square root of 7 squared, that's going to pull out a 7 on the outside. So for every time you circle a pair of numbers, whatever that pair is, you write that number down one time outside the radical. And then this right here is left over, so I'm going to leave that inside the radical. And this is the simplified version of the square root of 98. Now that is one way to work out this problem, and this is number 1 on page 2, by the way. Now I'm going to show you a different way, and this is really how I do this personally when I'm doing these, and it's very similar to this with a few smaller differences, and I'll show you what I mean by that. So first thing I'm going to do is I'm going to try and figure out my factor tree, just like we did over here. So again, I'm going to start with 2 because it's an even number, and these numbers get really big, and sometimes it's hard to figure out what will work. So I know 2 times 49 works. And what I'm going to do at this point is I'm going to circle a prime number anytime I get to it. That way I know I don't have to keep going with that stem of the tree. I can go over to this number now. And this one gives me 7 and 7. And again, I'm going to circle my prime numbers. Every time I get a prime number, I'm going to circle it. That way I know that that stem of the tree is done. And when I don't have any more stems to figure out, I know that I'm at the bottom. I'm done. I can't go any farther. From here, I am simply going to write out my answer. I look for my pairs. Here's a pair of 7s. I have 1 7 here and 1 7 here. What I do is I scratch them out and write them down on the outside. Do I have any more pairs and I'm talking about just the circled numbers. Are there any more pairs? No, there's not. So whatever is not paired up goes on the inside, just like that. And we got to the same answer with these. And I'm going to show you this again both ways on the next problem as well, because the next one can be done a few different ways. But I just wanted to show you my way and then a different way to learn it. There's other ways to do this as well. These are the two main ways right now. Now on number 2, we've got 128, or sorry, the square root of 128. And so we need to go ahead and start with our factor tree. And we'll do it the first way I showed you, like on the last problem. Let's get the lowest possible number and divide it into this number. So it's an even number again, so we know that 2 will go into it. 2 times what gives me 128? 64. Well, 64 keeps going. So let's see here. 64 will divide 2. It's an even number again, so 2 goes into that, and that gives me 32. Keep on going. We have another even number. I know 2 goes into that even number, so we have 2 times 16. Keep on going. We get 2 times 8. Keep on going, and we get 2 times 4. And keep on going because we still have an even number that's not a prime, and we finally have it where we have 2's all the way across the board here. That's a lot of 2's, right? Well, let's go ahead and draw out our radical sign. I'm going to put it over here. And now we need to count up how many 2's we had. 1, 2, 3, 4, 5, 6, 7. So I'm going to show you the long way to do this. 2 times 2 times 2. There's 4 of them. There's 5, 6, and 7. Alright, so now I've got all my 2's underneath the radical sign. And just like we did in the last problem, we're going to start circling off our pairs. So I have a pair of 2's right here. I have a pair of 2's right here. And I have a pair of 2's right here. Now, every single time I have a pair of 2's, I'm going to bring that out to the outside, but I'm only going to write down that number one time. So that pair comes out one time. This pair comes out one time. This pair comes out one time. Then we have the square root, and whatever is left over goes underneath. Whatever is not paired up goes underneath. Now, what am I doing with all these 2's on the outside? Remember, I'm multiplying these together. So 2 times 2 times 2. So 2 times 2 is 4. 4 times 2 is 8. So our final answer is going to be 8 square root of 2. Okay? Now, let's take a look at the same exact problem done my way. And from here on out, I'm only going to do things my way just because it helps me to stay a little bit more organized, and it might help some of you if you are having trouble with all these numbers. Okay? Well, let's take a look here. I know I'm going to start the same way we did over here. I know that 2 goes into 128 because it's an even number and it's a really big number, so I don't know all the multiples of 128 off my head. But I know 2 will go into it. So I'm going to do the same thing. Start with 2 and 64. Okay, and then what do I do with my prime numbers? Every time I get a prime number, I'm going to circle it because this helps me stay organized. This helps me keep everything where I need to. I can't go any farther. I can't take that stem of the tree any farther. So now I'm going to go back over here to 64. And instead of doing what we did over here and dividing by 2 again, I know that 64 will break down into 8 times 8. Okay? Now, are either of these numbers prime numbers? No, they are not. So let's go ahead and continue doing this. So I'm going to stem off from the 8, and 2 times 4. Again, I've got a prime number, so I circle it. Every single time you get to a prime, circle it. And then 4 becomes 2 times 2, and then I get a couple of prime numbers there, so I'm going to circle them. Every single time. This helps me stay organized because sometimes you're going to have 7 or 8 or even 12 or 15 numbers that you have to keep up with, and it's easier to find them out of all of these numbers if you circle them. Circle all your primes. And see, this stem, we didn't finish this one out yet, did we? So let's keep on going. So this one, and look, I already did an 8 over here, right? And this 8 broke down into 2, 2, and 2. So guess what this 8 is going to break down into? 2, 2, and 2. You'll start seeing patterns like that eventually when you're doing this because you'll do so many of these a lot of these numbers will repeat. And so you'll know immediately that if you come down to an 8, you know it's going to break down into 2 times 2 times 2. And then so you've got all these prime numbers here. So we have 1, 2, 3, 4, 5, 6, 7. Okay, so now what we're going to do, again, this is different from the first problem. I'm going to go through and I'm going to go ahead and match up my pairs. So here's a 2 and here's a 2. So that's a pair. I'm going to write that down. Here's a 2 and here's a 2. That's a pair. So I'm going to write that one down. Here's a 2, here's a 2. So I'm going to write that one down. And then this 2 does not have a pair, so it goes underneath the radical sign. 2 times 2 times 2 is 8 square root of 2. So you can see we got the same answer on both of these problems. They're both just done it a little bit different. I like the way on the right, you might like the way on the left, you might like both of them, it's really up to you. You get the same answer either way. Alright, so I'm going to skip number 3 and I'm going to go on to number 4. Just because if you can do number 3, you can do number 4. If you can do number 4, you can do number 3. They're pretty much the same type of problem. They're not going to be very difficult, I don't think, at this point. So let's go on through here and start with our factor tree. So what times what gives me 200? There's a lot of options here. Let's do, we'll do 4 and 50. Okay. Are either of these numbers prime? No, they are not. So I don't circle them. I just keep on going. So what times what gives me 4? 2 and 2. And there we go. We've got some primes. So I'm going to circle them. And now look, both of these stems are done because they have the red circles on them. So I'm going to go over to this stem now. Break this one down. What times what gives me 50? 5 and 10 does, I know that. There's other options there as well. You can do 2 times 25. You can do lots of things, but I'm going to go ahead and do it with these numbers. I know 5 is a prime number, so I'm going to go ahead and circle that. 10 is an even number, so it can keep on going. And that breaks down into 2 times 5. And then again, circle my primes. That way I know a couple of things. Keeps me organized. And it lets me know that all my stems are closed off. I'm not going to take any of them any farther than they are. So what we're going to do is we're going to go through and cross out our pairs. I've got a pair of 2's here, so cross them out, write down the number 2 one time. And then look here, I've got a 5 here and a 5 here. I'm going to cross those out, write it down. And then do I have any more pairs? Nope. But I do have this 2 kind of lingering right here, hanging out. So since it doesn't have a pair, it goes on the inside, square root of 2. And then to simplify this at the very end, just 2 times 5 gives me 10 square root of 2. And that's my final answer on that one. Now let's look over here at number 5 and take a look at this problem. Now this one is a variable, and we are trying to figure out what to do with it. Now earlier when we had an even exponent on our variable, like x to the 6th, so if we had like the square root of x to the 6th, what was my answer? I would just divide that by 2, and that gave me x cubed. Well, here's the problem with this, is that this is not an even number. It won't divide evenly by 2. Well, think about it like this, okay? Let's go ahead and divide that number by 2. Let's divide 7 divided by 2 and see what happens, okay? So I'm going to do this over here. I'm going to do this by hand, because if you put it in the calculator, it's just going to give you 3.5, which might be a little confusing with this. But here's what we're doing, all right? 2 goes into 7 how many times evenly? It goes 3 times. Well, 2 times 3 gives me 6. 7 minus 6 gives me a remainder of 1. So we have 3 remainder of 1. Y'all remember how to do that from way back in like 2nd grade? So we have 3 remainder 1. So that means my answer is going to be, whoops, I'm not going to have a square root symbol at all for my answer. My answer is going to be x to the 3rd. See, we got the 3 right here. X to the 3rd times the square root of x, because I had 1 as a remainder. So I have 1x that remainder remains underneath the radical, and then I take the rest and put them out here. So let's do another one kind of like that, okay? Let's do this next problem, which is the square root of x to the 5th. Now, if I divide 5 by 2, how many times is 2 going to go evenly? So 2 into 5. How many times is 2 going to go into 5? It's going to go 2 times. 2 times 2 is 4, which is going to leave me with a remainder of 1. So that means that my answer is going to be x squared. That's where we get this number right here. So x squared times the square root of x, because we had a remainder of 1. So there's basically saying there's one x that remains inside the radical sign, and then these two come out. So x squared times the square root of x. So basically, anytime you have an odd variable, doesn't matter what it is as long as it's an odd number. So let's say we had the square root of x to the, 13th. I know I'm going to have a remainder of one variable, and then divide this by 2, and how many times does it go evenly? 6 times. So x to the 6th. There you go. What about x to the 21st? So I'll do it like that right there. Again, I know I'm going to have x left over because it's an odd number, so you're going to have 1 left over. And then x to the 20th divided by 2 leaves me with x to the 10th. So you can always just basically subtract this number by 1 and put that x inside. That's going to leave me with x to the 20th, and then divide that by 2. That's going to give me x to the 10th. You can do that with any odd number exponent with a variable. Any one of them. Alright, so I skipped number 7. We went on to number 8 because number 8 is a little bit tougher, and it kind of does the exact same thing that number 7 does. So you'll get the same type of problem here. Well, we've got the square root of 54 times x to the 6th times x to the, or y to the 7th. So we've got a lot of stuff we've got to do here. Let's start with the number. Always start with the regular whole number if there's one out in front. Is 54 a perfect square? No, it's not. So we have to do our factor tree. So I'm going to come over here and do that. Okay, so we've got 54. Let's start our factor tree. I know that 2 times 27 goes. And then I'm going to circle my prime number. And then 27 breaks down into 3 times 9. And then I'm going to circle my prime number. And again, I'm circling the prime every time just so that I keep it organized. And then I know that 3 times 3 gives me 9, and then I circle those numbers, okay? Now, so we have this all factored out here. Let's go ahead and start putting our pairs together. I have a pair of 3's. There's a 3 and there's a 3, so that means a 3 is going to come out. And then what do I have left over? I have a 2 and a 3. Well, they don't have a pair to go with them, right? So I know that they are going to go on the inside. Oops, let me make sure I got the right color here. Yeah. So they're going to go on the inside. 2 times 3. Okay? So we're done with the 54, so I'm going to scratch that out. Now let's go with the x variable and see what we can do with it. X to the 6th, since it's got an even exponent, all we have to do is divide that by 2. So that means that we're going to be able to pull out x to the 3rd because 3 is half of 6. So we're done with that part of it. Now we're going to go up to y to the 7th. Now, like we just learned how to do, we know since it's an odd number, we're going to have a y left over on the inside. If you take one of those y's away and put it on the inside, that leaves you with y to the 6th. Y to the 6th divided by 2 is y to the 3rd. So now we've got to come down and simplify this, and the way to simplify this, 2 times 3, I'm just going to erase this and write it in here. 2 times 3 is going to give me 6. So we have 3x to the 3rd, y to the 3rd times the square root of 6y. That's a tough one. There's a lot of stuff going on there. That's why I like to go through and scratch numbers out as I use them. That way I know I'm done with them. A lot of the problems you're going to have, a lot of the issues you might have with getting these things right is just simply in organization skills. If you forgot that you've already done that part of the problem because you didn't scratch it off, or if you don't scratch anything off and you just completely ignore parts of it. It really helps to scratch them off as you go. That way you keep it organized. You know exactly where you are all the way through the process.